Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, question 4. Show that p cubed plus q cubed minus p plus q all to be cubed is equal to minus 3 times pq by p plus q. Okay, bit of a tongue twister. Right, so we have to expand out this side. So I have p cubed plus q cubed minus p plus q all to be cubed. Okay, so the expansion of this. So there's a few ways this gets taught. One is binomial expansion. Okay, so that would be 3, 0, 3, 1, 3, 2, 3, 3. Okay, it's actually in your log table somewhere. And then you go down in power, up in power. Here. Okay, the binomial theorem. But it can be kind of hard to read. So you're going from 0 to 3 in our case. Our n is 3. So that's where I'm getting my 3, 0, 3, 1, 3, 2, 3, 3. Okay, you then take the first term, your x term, and you go to the highest power. So n minus r, and r is normally 0. It doesn't have to be, but it normally is in your course. So it's the highest power of x, the lowest power of y. Okay, so it takes a small little while studying this, but if you can get your head around what is it saying in it, then it's there for you forevermore in the log tables. So down in powers in x. Do you see it's n minus r, it's n minus 1, n minus 2, all the way down to there's nothing left. So what does that mean? Well, my first term is p. So p to the highest power. Go down in powers, down in powers, down in powers till there's nothing left. Okay, and then you start off then, in this case, you'd have y to the power of 0, okay, y to the power of 1, y to the power of 2, y to the power of 3 in our case. Okay, so our other letter, or the one on the right, is q. So it's q to the power of 0, q to the power of 1, q to the power of 2, q to the power of 3. And in many places, the powers of zeros aren't written in as in the log tables. It's a plus in the middle, so these are all pluses. If it was a minus in the middle, this one's a plus, this is a minus, this is a plus, this is a minus. It's every second one. Okay, so this is NCR on your calculator. The NCR button is behind the divide by button. So what you put in is 3, and then you go shift, divide by, so that's the NCR, and you put in the 0. That's how you get it into your calculator. But either way, you get 1 for that. P to the power of 3 by anything to the power of 0 is 1. If you NCR into the calculator 3, 1, you get 3. P cubed by q, plus if you put 3, 2 into your calculator NCR, you'll get 3 p q squared. And if you put 3, 3 into the calculator, you'll get 1 again, you'll get 1 again, and you'll get q cubed for that one. Okay, so to tidy this one up then, okay, p cubed plus q cubed minus. Okay, so I'm minusing, and I'm putting this big square bracket around this because it's minus all of these terms. So it's p cubed plus 3p squared q plus 3pq squared plus q cubed. Okay, let's ripple through that minus. P cubed plus q cubed minus p cubed plus, no, all right, that should be a minus. Minus 3p squared q minus 3pq squared minus q squared. Q cubed, sorry. And let's cancel, they cancel, they cancel. So I have minus 3 p squared q minus 3p q squared. Okay, so now I look up here and I go, right, how do I make it look like that? Well, it looks like they're factoring out the highest common factor. So what's common between these two terms? The -3's, one of the p's, and one of the q's. Okay, so let's factor that out. So -3, one of the p's, one of the q's. What's left over? We have an extra p here. And here we have an extra q. We have factored out the minus. So it's a plus in here, okay? Because you need a minus in here. So now this minus by this plus gives me the minus in the middle. Okay, so that's the answer at the top. Okay, so this is a question that was examining binomial expansion. Okay, I did mention there was other ways of doing it. The other ways of doing it is very similar to what I'm doing, in that you go down in powers and up in powers, except you're using Pascal's triangle. And when it's the cubed one, that row, the coefficients are 1, 3, 3, 1. Okay, down in powers and up in powers. Okay, so you may have learnt it straight like that with Pascal's triangle, and you may be able to remember off Pascal's triangle. If you don't remember it, you'll always get it from the binomial expansion coefficients. So that's the same thing. And there's also a formula for it in the very start of some of the books, where you just learn off the expansion of a cubic function. Okay, either way, this is what you need. Right, part B. Okay, I'm just going to copy it onto a new page for us. Okay, hence or otherwise, find in terms of a and b the three values of x for which a minus x cubed plus b minus x squared minus a plus b minus 2x is less than 3. I don't know why I copied only a bit of it, because I do need the bit in front. Apologies, let me just copy again. Okay. So when you get a hence or an otherwise, okay, now, yeah, when you get a hence, that means what you've done in the part before leads on to this one. Okay, so that's important. That's the hence. When they give you an or otherwise, it means there's another way of doing it. Normally a longer way, but a perfectly acceptable way. And the perfectly acceptable way would be to do a cubic expansion here, a cubic expansion here, a cubic expansion here. Okay, and that would be perfectly okay. Right, I'm going to do it the hence way though, because I think there's great value in you learning how to do the hence way. So what you do when you get a question like this is you compare the two equations, this one and this one, and you equate the pieces together. So in other words, you match the like parts with the like parts. So you see the way this is a cubic function and this is cubic, and you see the way this is a cubic here and this is a cubic here, and this is a cubic and this is a cubic. Okay, so that means then I can equate. In other words, I can say that P must be the same as A minus X. Okay, the Q up here must be the same as B minus X. Sorry, ignore that 3. I just copied it over. Q is equal to B minus X. And P plus Q must be the same as A plus B minus 2x. Okay, so what we've done is we've compared both equations and we've let the like parts equal the like parts. Okay, that one is there and this one is here, and the minus signs match and everything. Okay, so now I'm going to take this part, because I know that this equation can also be written as this one, and in fact this is the simplified version of it. So let's take minus 3 PQ P plus Q, and let's sub in our A's and our B's, okay? Because remember, we have to try and find values for A's and B's, okay? So let's try that. So I have minus 3. Instead of P, I'm putting in A minus X. Instead of Q, I'm putting in B minus X. And instead of P plus Q, I'm putting in this. A plus B minus 2X. Okay, and it's equal to 0. Okay. Yeah, and what we do here now is we equate the coefficients. Okay, which is a little bit strange on this one because all that's on the right-hand side is 0, okay? Which means all of these little factors that we have here, it's written now as a series of factors, and we can let each factor equal 0. Okay, so let's do that. Let's A minus X to be 0. Let's let this factor equal 0. Let's let this factor equal 0. So it's a bit like a quadratic with 2 factors equal to 0, and you let each bracket equal 0. So that's really what I'm doing here. Okay, so let's find the 3 values of X in terms of A and B. Forget my little A there. Okay, so A is equal to X in that case, or X is equal to A. B is equal to X in that case, or X is equal to B, my 3 values of X. And let's do this one. I have A plus B equal to 2X. Or let's just swap the sides, and let's divide across by 2. So they are my 3 values of X in terms of A and B. Okay, so the important takeaway in such a question, when you get 2 equations like this that have the same look and feel about them, equate the pieces together.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.